Ever since humans developed instruments that could let them see light years into the distance, they have been fascinated to discover a great many things about the universe. New nebula, supernova, and gas giants are all on the list. But the most practical endeavor until now has been in discovering other exoplanets in distant solar systems that have a resemblance to our own. Habitable planets have been a hotly researched topic since 1992, when the first signs of exoplanets with biosignatures mirroring Earth's were discovered. Since then, we have made many major advances in the search for other hospitable planets, which have the chemical makeup which complements our own. The list is dominated by exoplanets from the Kepler solar system, though most recently, the TRAPPIST solar system has also been preferred as a likely candidate. There is an entire list on Wikipedia of potentially habitable exoplanets that catalogs over 70 different possible planets that humans could call home. The evidence that these planets can support life is, at best, circumstantial, and there is no conclusive proof that they contain the atmosphere and chemical makeup of a human-friendly environment. A big problem in this regard is to ascertain the possibility of natural sources of water. A lot of the planets that we have observed recently with the James Webb Space Telescope, such as the TRAPPIST-1e, have a good chance of sustaining human life, but bring no promise of water. But all that could change with the breakthrough of a team of NASA scientists. They have made a promising discovery that could upend the established limitations we have heretofore been victim of. What did they find out? Well, let's discover for ourselves. On August 24, 2022, a team of international researchers, headed by Dr. Charles Cadu of the University of Montreal, discovered an exoplanet some 100 light years from Earth. The exoplanet in question, named TOI-1452b, is slightly larger than Earth and resides in the Draco constellation. Scientists have identified more than 5,000 different habitable exoplanets. So what makes this one so special? It is an oasis, an Atlantis of the cosmos. It is an ocean planet and much of, if not all, of its surface is covered in a deep layer of water, much in the same way as the moons of Jupiter. But whereas Ganymede, Castello, and Euphora have water depths under their surface, this exoplanet has no such handicap. Lying in the Goldilocks region means that it isn't too close to its sun to get fried and isn't too far away to freeze over. A suitable distance from its star where it is neither too hot nor too cold, and the unique chemical makeup for the ubiquity of water. In an article published today in the Astronomical Journal, Dr. Charles describes their observations and calculations to give a rough estimate of the nature and characteristics of the planet. Dr. Charles, a member of the Institute for Research on Exoplanets, as a PhD student at the University of Montreal, it is his job to observe potential candidates picked up by NASA's test of the Transiting Exoplanet Survey satellite. As the name suggests, the test analyzes and surveys planets near our solar system. It was a find from the test that put Dr. Charles on the trial of TOI-1452b. The signals from the test indicate that the brightness of the planet was dwindling ever so slightly over an 11-day period, which led them to deduce that it is roughly 70% greater than Earth in both mass and size. The OMM played a crucial role in confirming the nature of the signal and estimating the planet's radius, explained Dr. Charles. This was no routine check. We had to make sure the signal detected by tests was caused by an exoplanet circling TOI-1452, the largest of the two stars in that binary system. To find conclusive evidence of the true nature of the exoplanet, he made his way over to the Planetary Exploration Science Technology Office, or PESTO, a sister branch of the Exoplanet Research Institute. He used a special camera installed on the telescope to confirm the origins of the signal. He would later go on to recognize the OMM telescope as a major aid in their findings. The OMM played a crucial role in confirming the nature of the signal and estimating the planet's radius. This was no routine check. We had to make sure the signal detected by tests was caused by an exoplanet circling TOI-1452, the largest of the two stars in that binary system. The star, TOI-1452, is much smaller than our own, but is part of the binary system. The two stars orbit each other and are separated by a distance of 97 astronomical units. That's 97 times the distance between the Earth and the Sun. The TESS telescope made them out to be a single point, but the high resolution of the PESTO made it easier to distinguish them as two separate entities. And it was later confirmed by a team of Japanese scientists that the exoplanet does indeed revolve around TOI-1452. The discovery of the planet only marked the beginning of the discovery To get a closer look at the exoplanet, the researchers needed some more firepower to identify key elements of the planet's geology and biosignatures. This was done to realize the true potential of the exoplanet as a potential habitat, one suitable for human residence. To determine the planet's mass more precisely, they made use of the spiral. This telescope in Hawaii is ideal for studying low-mass Ooredoo stars. Since it operates on infrared radiation, much like the JWST, it can give researchers a clearer picture of the star, which emits infrared radiation as its major constituent. Determining the mass of the star took well over 50 hours and was found to be nearly 5 times that of Earth's. The researchers then went on to develop analytical methods that could be used to isolate the luminous intensity of the planet from a sample taken by the spiral. The analysts described the mass, the radius, and the density of the TOI-1452b. In many ways, it resembles Earth, but the data collected proved otherwise. Now, we may think that Earth is a planet with an abundance of water. Nearly 70% of the surface is covered with the life-sustaining compound, but when taken collectively to account for the mass of the planet, it makes up a meager 1% of the total mass of our blue planet. The size and density of the TOI-1452b are indicative of the fact that it is dominated by larger materials, which make up the bulk of its mass. Such worlds are dubbed ocean planets, Dr. Charles explained. TOI-1452b is one of the best candidates for an ocean planet that we have found to date. Its radius and mass suggests a much lower density than what one would expect for a planet that is made up of metal and rock, like Earth. Analysts shows that water makes up about 30% of its mass. This is comparable to Saturn's moons, Titan and Enceladus, though the bulk of their water is either frozen or buried deep underground. The planet would make an excellent candidate for further inspection by the James Webb Space Telescope. It is one of the few ocean planets that scientists have conclusively identified, and it is close enough to our solar system that we can test and conduct further investigations. As luck would have it, the JWST also overlooks the region where the exoplanet resides all year round. The JWST technicians expressed their enthusiasm to learn more about the planet. The spokesperson, Duyan, who overviewed the conception of James Webb's NIRIS, remarked, "Our observations with the Webb telescope will be essential to better understanding TOI-1452b. As soon as we can, we will book time on Webb to observe this strange and wonderful world." For a planet to be habitable, it needs to have 3 things: liquid water, a solid surface, and a thin atmosphere for certain gases. So far, the TOI-1452b is a viable candidate, but we'll need to wait until the JWST can provide conclusive proof. So there you are, guys. I hope this video offers some good insight. If you enjoyed it, be sure to hit the like button and subscribe for more content like this. And as always, thanks for watching.